Hello, folks. Is that really what I think it is? I hear you say. And yes, it is. This is a Tesla Model 3 rear drive unit, which for this is a Tesla Model 3 rear drive unit that, as some of you may know, I have been working on an on and off basis now for several years. And unfortunately, it's also one of the things that I have failed miserably to get working outside of its parent vehicle. And there have been several reasons for that. My own stupidity being one of them, and having to move house in the middle of it being the second one. But this particular drive unit that you see here was recently donated to me, and this kind of has reinvigorated my interest, because whereas the Model 3 components that I currently have were very kindly given to me as a loan so I could work on them, they were never mine, so I couldn't really go too crazy tearing into them. But this one here is mine, and I can go nuts. So, one of the, I guess, advantages, if you want to call it that, of having been away from this for so long is that it's given me a little bit of perspective and some new ideas. So, firstly, let's talk about why we have failed. So why has Elon here been kicking my butt, as the saying goes, for so long, when I have had, much better successes in the past with Model S parts? Well, the primary problem that we have with the inverter in the Model 3 drive unit is that it is all one PCB. So it's got all of the MOSFET gate driving and current sensing and voltage sensing and all the other power supplies and all that kind of stuff on one PCB, as well as the main microcontroller that runs the whole thing. If you want to know more about that, I suggest you have a look at some of my previous in-depth reverse engineering videos, because they're very boring. So that meant that I wasn't able to just design a little logic board around the open inverter system like I had been for the Model S drive units. So I did have this idea where I was going to make a little mod board, so kind of like, I guess, in the same genre as the PlayStation and various game console modification chips, where you would solder it to various points on the board. I did design one. I did put it on one of the drive units, and I did actually run the drive unit with that, but it was really horrible. There was wires everywhere, and I just couldn't make myself like it. So, little bit of a hiatus then after that, and then what happened was there's a very nice chap, member of the Open Inverter Forum, that came along, and he has taken on and is still currently working on the not insignificant task of writing a new open source firmware that will run on the Texas Instruments C2000 microcontroller that's in our drive unit. And we can in fact erase the flash of that microcontroller over JTAG, as I demonstrated in previous episodes, and we can load on our own custom firmware. But that is not an easy task, folks. It's way beyond me. So that's not something that I've been able to actively contribute to, unfortunately. Best I'd be able to do would be to flash it onto a drive unit and try to run it and see how it behaves and things like that. But me getting into that level of software development is just not going to happen, sadly. So, another hiatus then while I was moving house. As I say, now we have this drive unit here, and I'm very keen to revisit the project again. So that's what we're doing. And I'm hopefully going to be doing over the next few weeks with you. Just two options left. Okay, so we tried making a mod board to put on the existing PCB, but it's horrible. We are working on, well, we, the royal we, are working on the firmware to just flash in there. So what's left? Well, option number 3, or behind door number 3, as they say, is to attempt to run the drive unit as is, using its own Tesla firmware, just by feeding it the necessary CAN signals. Now that sounds, from a high level, to be the ideal thing to do. And you would be forgiven for saying, hang on a minute, Damien, why did you not just do that in the first place? It's not like you don't have CAN logs from Tesla Model 3. And I do. But there's a catch. See, these Model 3 drive units follow along in what happened in some of the later Model S ones, in that they have what is, I guess, known as the Immobilizer. And the Immobilizer in this case is basically a data exchange between the microcontroller in the drive unit and another microcontroller in one of the other modules within the Model 3. I forget which one it is, whether it's VC front or VC left or whatever it is, but it doesn't really matter for the purposes of what we're doing here. So the problem is, we wake this thing up and we ask it to go into drive. It's going to query that module that we don't have. And it's going to say, you know, hello, I'm such and such. Would you like to reply to me with your secret handshake, please? And when we don't provide the secret handshake, it's not going to spin. So how do we circumvent that? Well, there's a number of ways that that can be done. And in fact, there are some commercial controllers available, to the best of my knowledge, that can run the Model 3 drive unit via CAN. So how did they do that? Well, I don't actually know for fact, but there's really probably only one way that would function. So this is my guess, best I've got at the minute, which would be, we would extract a firmware where we know the secret handshake for. We would then have the answer to that. So we could run, let's say we had drive unit here, and if I had, let's call it VC front for the sake of conversation, from the car, theoretically I could wire up a big mess of cables here on the floor, get this drive unit to run, and then we could capture that handshake. We could then play that back to the drive unit, get rid of all the wiring on the floor, and this particular drive unit would run happily. But if we attempted to do that with another one, of course, the handshake would be a little bit different and that wouldn't work. So But what if we knew how to program the firmware into the drive unit over CAN? Then what we could do is we could take the firmware out of this one, and for any drive unit that we wanted to run, we could squirt that firmware into it, and then we would have the correct handshake, secret handshake. So that would be one way to do it. So you could reasonably again say to me, Damien, why don't you just do that? Well, the solutions that I always try to pursue are those that can be used in a fully open environment, and that unfortunately is not one of them. So how else could we do it? Well, another way is if we extracted the firmware from this drive unit and were clever enough, which I'm not, to disassemble it, find out where it looks for the secret handshake, and either tell it not to bother with that, so just change a bit so that it just skips that particular part, or just make the handshake code all zeros or something like that. Then we would have a, let's call it a clean firmware that we could then squirt into any drive unit that we wish to run. So why don't you just do that, Damien? Did you miss the part where I said I'm not clever enough? See, I'm not clever enough. But let's say that, let's say I wired myself up to a supercomputer with a USB cable, and I made myself clever enough temporarily, probably at the cost of several years of my life. But hey, I can do that for you guys. And I became clever enough for like 20 minutes or something and managed to do that. So I would now have a binary file. So then I would have a binary file that belongs to Tesla. So I can't very well say, hey, look, GitHub, upload, here it is, flash this onto your drive unit, send it all zeros as part of the handshake message, and away you go. Because then Elon's gonna be a Falcon 9 coming through the roof of the barn, and the roof of the barn, yeah, it's not gonna win. The Falcon 9 is just gonna squirt in here, and it's gonna scratch the Panzer's paint. And you know how long it took me to get the Panzer painted? We're not gonna risk that. So, are there any other ways? And this is where I'm gonna do something stupid, okay? I want you to imagine that you're driving down our road and you see a road sign that says bridge out ahead. Well, a sane person would stop, turn around, go back and find another way, because you're not going to get to your destination because there's a bridge out. And you can think of the bridge out as being the handshakey code thingy, immobilizer in here. So I'm going to drive down the road, I'm going to ignore the signs for you, and we're going to get as far as we can with the CAN, even though we know the bridge is out and we're going to go, okay? Because I know what you guys are thinking. You're thinking, but Damien, try this, but Damien, try that. So yes, I will. I'll do that for you, because that's what you pay me to do. So we're going to wire this thing up, and we're going to pretend like we can actually make it work, even though there's a bridge out. And I'm going to video that. And you're going to get to see me fail. And that's going to hurt my big ass ego. So, I'm doing this for you, okay? So that's what we're going to do. So we're going to try something knowing that we're going to fail, but there'll be some learning here for us. So that's why we're going to do that. Now, that's option number 3, I hear you say. Yes, what's option number 4? No. Option number 4 is much more in, as they say these days, in my wheelhouse. So let's have a look at option number 4. Is it me, or does this look like the United States? Look like a map of the United States. I know Florida's missing. Is Florida missing? I think Florida's missing. But if I look, because like, I don't know. But anyway, it'd be pretty cool if it was made in the shape of the country where it was designed. Because put it that way, does it do Ireland? Not really. So anyway, enough about that. So yes, hello. Wait a second. What's this? This is the logic board. Can't really see through the holes, so I'll have to kind of scooch around like this. Here it is. That's the front. That's the back. So this is a logic board from Tesla Model 3 inverter. Now remember I said at the beginning of this stupid and long and boring video that we couldn't just design a logic board for this because it's all in one and it's got... This is the microcontroller, the little Elon brain. Look at him in there tweeting away. Right here we have all our gate drivers. Look at those gate driver chips. Gate drivers. Down here we have our current sensors for sensing current, and up here we have our power supply stage and all this. And yes, I reverse engineered the smeg out of this thing. You can see it in some of my past videos, and we'll have some new ones for you after I fail and I go off the bridge and I crawl out of the car and spend 6 months in hospital in traction, all for you guys. And on the back, there's some more stuff which we hadn't been able to see before, but now we can see. I can't see you, but you can see me. Can you? No. Anyway. So, this is going to be the Mount Everest of logic boards, because what I'm going to do is I'm going to design this. Yeah. I'm going to go ahead and I'm going to redesign this board, and we're going to copy all of the gate driver stage, which I am currently finalizing the circuitry of. We're going to take the current sensors off the back. We're going to have the current sensors. We're going to have, there's a lot of the kind of glue logic in there. We're going to do the power supply a little bit differently. But ultimately, there's going to be an open inverter version of this board coming your way in early 2023. So, how are we going to do that? Because as much as I know that Johannes would love to run this little trivial motor from one, STM32F103, there is quite a bit of other things going on here, and I didn't necessarily want to go ahead and have everything bolted on to one micro, because it means there's a different code base for the Model 3 stuff than from the open inverter side. Now, this is again one of the reasons I didn't pursue something like this in the original case, and found myself, as I say, in some of those various hiatuses, and I had a thought, and the thought is something like this. Let's put 2 micros on there. Let's put a 32F103 on there, whose sole job will be making Elon back here spin. And then I'm going to put a 107 on there. So same one as I have in the VCU, which I'm reasonably familiar with. And its job will be doing communication, because it's a connectivity line part. So it's going to do things like configuring the gate drivers over SPI, configuring the power supply over SPI, monitoring for any craziness. It'll be doing all the communications outside over CAN, and there's LIN here for the oil pump and all of those kind of things. So we're going to offload all of the peripheral stuff from the 32F103, let that do all of the motor control, and then the 107 will be doing all of the communication stuff for us. So it'll be it won't have a hard time. And that means then that we will have the ability to run all of the latest updates from the Open Inverter FOC code base. We can just put them in here and it'll just run. And Johannes has made some, and other people obviously have assisted and made some great strides with the FOC system that's currently running in that code. So that's where we're at, folks. So I thought I would give you a boring talking video today because it's kind of turned into one of these days where I had to do a lot of stuff this morning and it's too early to quit, but I kind of want to do something worthwhile. So thought I'd introduce you and give you a much needed update on where we are with our Model 3 drive units. So that's where we're at. That's where we are. So what I've got behind me here now is I've got a box with a load of connectors and so on, because one of the first things that we're going to have to do, whether we, redesign the PCB or whether we drive off the destroyed bridge of trying to run it via CAN without the immobilizer data, we're still going to need to wire it up. So we're still going to need the 30-pin main connector. We're going to need the connector for the resolver. And we're going to need the connector for the oil pump. So went ahead and I've collected all of those parts with pins and all this. So I'm going to be getting a list of all that together for you. So in the first proper episode of this saga, we'll be showing you, we're just showing you the wiring up the various connectors and so forth. We'll wire it for the OEM system firstly, because we'll obviously, go and drive off the bridge first, and then when I, as I say, get myself back from that, we'll go ahead and start working on the PCB design. So in terms of the PCB design, the things that I have yet to do is just there's a little bit more of the gate driver circuitry that I need to work out. I've worked out around the control chip, but it's kind of the push-pull. They have a P and an N MOSFET in there for boosting the output from the gate drive chip into the SiC MOSFET, so we need to work on that. And there's a little bit around the power supply stage that I need to better understand also. So I think this video has gone on for long enough, so I'll leave you there. Don't forget to dislike, unshare, don't subscribe, don't check the links in the description. Pete's sake, don't support me, especially financially, because then I start doing stuff like this and designing PCBs and stuff. And as I say, who wants that? So, but do join me for your own entertainment in the next episode when I have this thing wired up and we start foolishly trying to make it operate via CAN. Because I know the internet wants that, so I have to try, right? Okay. Until next time, happy detour finding.